So we're going to study about solutions of right triangles. Right triangles are nothing but right angled triangles. Triangles like these, where at least one angle or exactly one angle is 90 degrees. These kind of right triangles we're going to talk about. So all the trigonometric ratios that we have studied of sine, cosine, tangent, cotangent, secant and cosecant, all these characterize this right angled triangle only. So we select an angle, let's say this angle we call it theta, and then there is an adjacent side and there is an opposite side. So what is sine of theta, what is cos of theta, what is tan of theta, etc., etc., is defined with reference to this right angled triangle. Here's a quick introduction about what we're going to do today. We're going to solve simple two-dimensional problems where we have right angle triangles. Some of the sides, either the adjacent side or the opposite side, is known to us, and we have to find the other two sides. How do we find these other two sides? Using the trigonometric ratios that we have studied before. To solve any right angle triangle, it simply means that we have to find the values that are unknown. So sometimes this can be unknown to us, sometimes this can be unknown, sometimes the angles can also be unknown. Okay, so whatever is unknown, we just have to find that. That's all there is to solving simple 2D problems based on right angled triangles. So we have an example in front of us. The measure of an angle, angle A, is given to us, and the side CB or BC, which is the opposite side, that's given to us. Can you find out the adjacent side? Think of a trigonometric ratio, sine, cosine, tangent, cotangent, that has perpendicular or opposite side in its formula.
The tan and the sine.
Very good. Okay, so you say tan 30 degrees and sine 30 degrees. Very good. You've narrowed it down now. Now tell me, tan theta, its opposite side, that means perpendicular, upon what? And sine theta is perpendicular upon what? Can you tell me?
So tan theta is opposite side by adjacent side. Sin theta is opposite side by the hypotenuse.
All right. So can I write x here and y here?
Yeah, sir.
Okay. What did you have to find out? You had to find out AB. So which trigonometric ratio will help you here? Sine or tangent? Which one will help you?
Um, tan.
Yes, tangent will help you, okay? And that's why we'll choose this and we'll erase sine. So this is how you decide which trigonometric ratio to pick based on what we have to find out. If we had to find out the hypotenuse, we would have picked the sine of angle A. But here tan of angle A will work for me. So let's figure out the answer now. And what is the value of tan 30? You remember, you have the list.
Tan 30, 1 by root 3, right?
Correct. Okay. So 1 upon root 3. So the value of x becomes 20 root 3. See, simple enough, right?
Yeah, sir.
Which trigonometric ratio shall I pick up? Which trigonometric ratio is going to help me find answers? All right. So this was just a warm up. Let's solve this one. Okay. Here we have two right angle triangles embedded in one right angle triangle. So basically we have, in total we have three right angle triangles. Let me name them. So this is A, B, C, and this one I'll name as D. So ABD is one right angle triangle. ACD is another right angle triangle. Yeah, for now we just know that these two are the right angle triangles. Okay, we won't talk about the third one. So here in this question, we have two right angled triangles and you have to find the value of x. This time x is this angle. In any right angle triangle, let's go back. In any right angle triangle, if I have one length and one angle given, or two lengths given, any two quantities that are given to me, I can figure out all the rest of the quantities easily using trigonometric ratios. This you should write down. If we have any two quantities given to us, that means I can figure out all the rest of the quantities as well. The adjacent side, the hypotenuse, the angles, everything. So if I look at this triangle ADC, I see that there is a side given to me. Side DC is given to me, that's 30 units. And the angle A is given to me, that's 60 degrees. So if I want, I can figure out all the other lengths. But which length is going to help me more? My ultimate aim is to figure out the value of x. I just want this. So I should figure out the length AD. That's going to help me. Figuring out AC won't help me much with x. So let's figure out AD. What would you say?
Okay.
Yeah.
Hello.
Yes, I can hear you. Tell me which trigonometric ratio will help me find out the length AD.
AD. Okay. So they have given the hypotenuse. So I think it would be cosine.
Okay. Cosine. But cosine of 60 degrees. Okay, let's add it. Cosine of 60 degrees is equal to AD upon the hypotenuse, right? That means AC.
Yes, sir.
But do you know the value of AC?
No.
No. So this won't help me that much. This won't help me directly. Is there any other trigonometric ratio? Think of it. Okay. Tan 60 degrees is equal to DC or CD upon AD. This is definitely going to help me because I know the value of CD or DC. So tan 60 is equal to root 3 and DC or CD is 30 units. AD is unknown to me. Let me just call it P for now. Okay, let's call this P. So the value of P is going to be 30 upon root 3. This you can write as 3 into 10 upon root 3. This gets cancelled. You get 10 root 3 units. Okay. You understand? I hope you understand the calculation. Now, I have figured out this length. This is 10 root 3. I have to find out this angle. I have been given some other measurement also. I know what is the value of AB. This is the hypotenuse, this is the perpendicular or the opposite side. Which trigonometric ratio relates the opposite side and the hypotenuse? Which trigonometric ratio relates the perpendicular and the hypotenuse?
So what is that? The sine.
Yes, it's sine. That's correct. So, right, sine of x is equal to perpendicular, which is 10 root 3 upon hypotenuse, which is 20. Now, this will simplify and it will give me root 3 by 2. Sine of which angle is equal to root 3 by 2? The value of x is then 60 degrees and we are on answer. I'm going to let you solve the next question, okay? So take 5 minutes. It's an easy enough question, very similar to the last one we did. Okay, so let's look at the solution now. We have to find the length AB. Now, AB is composed of two lengths, part AP and part PB. Let me call those X and Y. Let's first find out the value of X. For X, we are going to consider this triangle, triangle QPA or AQP, this triangle. In this triangle, I know the perpendicular, I have to find the base. Perpendicular upon base, that is tan of 30 degrees, isn't it?
Yes, sir.
Okay, so this is going to give me the value of X because I know perpendicular is 10 and the base is what I have to find out. So quickly let me find out. Tan 30 is 1 upon root 3. This is 10 upon x. So x is 10 root 3.
Yeah. Okay.
Okay. Now, similarly, we are going to do a very similar exercise for the triangle PBR. Okay. In triangle PBR, so we have the adjacent side and we have to figure out the opposite side. So basically, tan of 45 relates the adjacent side to the opposite side, right? So this is going to be y upon 8. Tan 45 is 1, so this will give me y equals 8. So the value of y is 8. Any doubts?
Second. Mm.
Finally, we have to figure out the value of AB. And AB is equal to this
X
plus,
plus Y.
yes. So that's 10 root 3 plus 8. Depends on how the answer is given to you. If it is a multiple choice question, then you might have to adjust this accordingly. Otherwise, this is your answer. You use whatever units. So here it's centimeters. So 10 root 3 plus 8 centimeters. That's your answer.